Okay, this video we're going to cover a technique called completing the square. We use this technique to help us convert from our standard form into vertex form. So far between all the other forms, the last one is going from standard form into vertex form. So again, looking at this equation, we're headed this direction. Now notice when we look at this, the a value, so just some things to notice before we go. The a value is the same, right? In both of these, we've talked about that. So as we're moving this into vertex form, if there is an a value, we will always pull that a value all the way out front. And then notice, right, that we end up with an h term and a k term, and this term is nicely squared. If we were to write that out, remember that means that there's two of those. This would look like a times x minus h plus k. So there's always this value kind of on the end here, and then we have these two pieces that are identical, and because they're identical, we write them as x minus h squared, and then we have our a value. So just keep that in mind as we go. What we're going to do is we're going to pull the a value out. We're going to move the c value off to the end so that we can kind of figure out what that k value would be. And then we're going to make it be factorable in a way that creates this nice little perfect squared piece, okay? So you can kind of read through these steps. If you look at this one, kind of the steps, this first equation it says is in standard form. So we've got y equals x squared minus 20x plus 62. Notice we just moved the 62 off to the side. Again, that's going to relate to the k value in the end, but we want to create some space so that we can make this be factorable in the way that we want. Now, if I want to make this be factorable and I'm trying to break this down into pieces that are identical, x and x, and they need to have, subtract to 20, but they have to be the same. Notice in order to get those the same, it has to be 10 and 10 in order for that to add to 20, and it would have to be negative 10 and negative 10. So really the only number that would be perfect for us to add in to make this a nice little factorable trinomial would be negative 10 times negative 10, or in other words, positive 100. And now it's weird to think, well, we can just add in a number that we want so that it factors nicely. The higher you go in mathematics, the more you'll realize you have these flexibilities if we stay within the rules. So the rule for an equation, it just has to stay balanced. So we have x squared minus 20x. If we add 100, that's fine, as long as we then subtract 100. So notice down here, we've added 100 into the equation and subtracted again 100 here. Now again, why 100? Because that's the number that works to split this up into two even pieces so that we end up with our x minus 10 squared, which is vertex form. So again, when I'm looking at this, the rule of thumb is that we take half the middle term. We need to split that up evenly, and then we just square that because we know that the last times last would give us that number right there. So that would be 100. Okay. So here's the process. We're going to go through a bunch of examples. Notice this one didn't have an a value bigger than 1, so we didn't have to pull any a value out. We'll look at a few of those as well. So here at the top, we've got two examples. Again, our goal is to write this into vertex form. So we go here, there's no a value bigger than 1, so we do x squared minus 20x. This one's very similar to the last one. And I move the 3 off to the right. Now again, I want to be able to create something that's factorable. So I take half this middle term and I square it to find that perfect value. So this right here, negative 10 squared is 100, just like the last example. And if I add 100, that's fine as long as I then subtract 100. Notice then I have this trinomial here. So when I break that down, that's going to be that x minus 10 times x minus 10. Breaks down nicely. And then we have 3 minus 100, which is negative 97. So this would be y equals x minus 10 quantity squared when we put those two together, minus 97. That right there would be our vertex form. Example 2, same process. So the a value is just 1. So we've got n squared plus 8n, and I move the 10 off to the side. Again, if I want to break this up evenly, then I take half the middle term and I square that. So this would be positive 16. That means I need to subtract 16 off to the side. Now again, as I'm factoring, remember it's this trinomial that's breaking down into n plus 4 and n plus 4. Sometimes I get asked, well, where did the 16 go, right? Well, those three terms, remember, factor into two binomials. So we can then combine that negative 10 and negative 16 for the end there. And our final version we would write is n plus 4 squared minus 26. Now what happens if there is an a value? Again, you just have to divide that out. And it looks a little bit weird because we've been pulling greatest common factors out, but we always divide out of every term. Well, notice here the 45 gets moved to the outside and then it just stays on the outside, right? Until we can combine it with something. So we're not going to divide this 2 out of the 45 and create a fraction or a decimal. The 2 is only going to relate to the first part of our vertex form, and then notice it has to stay all the way because that's that stretch or shrink. So as we go on this one, notice the 2 gets pulled out of just these two terms. So we've got 2 and then parenthesis x squared minus 10x. Then they take half of this term, so negative 5, and square it, and that's where they get that 25. Now notice they add in a 25 and then suddenly subtract a 50 out here. When you have a greatest common factor, notice that what you've really added in, if I were to distribute this out, 2 times 25 is 50. So you really added a 50 into that equation by putting that 25 in the parentheses. So that's why we're subtracting 50 to the outside to balance it. Then notice down below you've got a 2 here. We've got x minus 5, factoring that trinomial. And then you have these two combining to give you the negative 5. And then writing that in the final vertex form. So let's try a couple of these ones. Example 3. Again, we're going to write, y is equal to, I'm going to pull the 2 out of just these two terms. And then the negative 5 is going to go off to the side. So I'm going to have x squared plus 6x. Again, once I've divided the 2 out, now I can do half the middle term and square that. So I'm going to add a 9 in here. But remember, what we really added was 2 times 9, or in other words, 18. So when I subtract this, I'm going to subtract 18 on the end. Now when I factor that, I'm going to have 2. Then I break this down to x and x. Everything's positive. 9 breaks up to 3 and 3, right? That adds to 6. And we have a negative 23 here on the end. So our final vertex form would be writing the x plus 3 together, squared minus 23. We look at the next example. So we've got f of x, or y equals, I'm going to pull that 3 out once again and move the 7 off to the end. And it's only being pulled out of these two terms. So we've got x squared minus 4x. Again, if I want to find that perfect value, I take half the middle term and square it. So I end up with positive 4 here. But again, recall that greatest common factor multiplies by that 4. So I really added 12 in there, so I want to subtract 12 on the end. That allows me to factor this trinomial part. So that breaks down to x minus 2, and on the end there I've got negative 5. That leaves me with 3. We put the x minus 2's together, and we've got subtract 5 on the end there. Okay. Now this last question, or these last two, kind of looking at this, it says if the b value, the middle term of a coefficient, was an odd number, and we're trying to take half of that number, right? What challenge might we run into? Can it be done? The answer is yes, it can. You're just going to have to deal with fractions. So just know that you'll create fractions. So we'll learn some other methods that we kind of avoid this just so that we don't have to throw fractions around as much. But I do want to show you what it would look like. So here on example 5, if I take y is equal to, and I divide the 2 out of this first part and leave that negative 10 off to the end, even though it's divisible by 2, we're going to leave it out there. We would get x squared plus 7 halves, or 7 divided by 2x. Now, it doesn't look too bad, right? We've got a fraction in there. But when we take half the middle term, that's 7/4. And then we square it to put it back in here, or to put it in. So that means we're adding here, and to square a fraction, you just square the top. So 7 times 7 is 49, 4 times 4 is 16. Also, that's not too bad, but notice what we really added to the equation was 2 times this fraction, which is actually 49 over 8. So on the outside, we would need to subtract 49 over 8. So again, it's the same process, but it just looks a little bit scarier maybe because there's fractions involved. But again, it's the same idea here. And we would end up with something looking like x plus 7/4, x plus 7/4. This is like negative 80 over 8, right? Minus 49 over 8, just creating like a common denominator. So if I was writing this in Vertex form, I'd have the 2 x plus 7/4 squared, and then those two negatives are going to combine to negative 129 over 8. So again, same process, you just have fractions involved. Example 6 I included because I wanted us to look at what happens if the a value is negative. If the a value is negative, again, same process, just be very careful that you are aware of the signs that are changing. So when you factor out a negative 6, you leave an x squared right there, and a negative 6 out of negative 12 is a positive 2x, and then let's leave the 9 out there. So just be very careful with those signs, and if we take half the middle term, that's 1, and we square that, we end up with adding 1 here. But remember, you had a negative 6, so negative 6 times 1 is negative 6. So this time, if you've already subtracted 6 into the equation, you need to add 6 out on the outside of the equation. So we would get y is equal to negative 6, and then we factor this trinomial. And again, the more you do this, you won't have to write this middle step necessarily, because we'll recognize we can always write that x plus 1 together. So we would have equals negative 6, x plus 1 squared plus 15.